Welcome back, dear students, to the Byte family, to this our some channel Byte by Byte, where we break down the complexity students might face when it comes to advanced level computer science 795 or advanced level ICT 796. In the previous lessons, we introduced computer organization. We went further to look at the von Neumann architecture and the Harvard architecture, and we saw the difference between them. And today, we are looking at an important concept which is known as the Flynn's taxonomy. Parallel computer architecture. This is a class of computer system that achieves high performance by using multiple processing elements. It can be cores, it can be processors, or it can be specialized units. That we say parallel. That work together simultaneously to solve a single problem or handle multiple tasks at the same time. That we call parallel computer architecture. Now, these architectures are classified by Flynn's taxonomy. He identified two types of information streams: the instruction stream, which is the flow of instruction into the processing unit, and the data stream, which is the flow of the data on which the instruction are performed. So Flint, in classifying computer according to the parallel, according to how when classifying computer according to the level of parallelism, or let us say parallel characteristics, he identified two types of streams: the instruction stream and the data stream. He classified computer architectures according to how many instruction streams, that is the processes, and data streams they can process simultaneously, dividing them into four categories: the SISD, the SIMD, the MISD, and finally the MIMD. Now, let us look at them. One, single instruction, single data, SISD systems. A single instruction, single data machine is a uniprocessor machine which receives a single stream of instruction that operate on a single stream of data. That's why we have the name single instruction, single data. And it is a uniprocessor machine because it receives a single stream of instruction and it operates on a single stream of data. In SISD machines, instructions are executed sequentially and there is no parallelism at the instruction level. These machines are also called sequential or serial processor machines. They are typical example of von Neumann's computer model. Take note of paper 1, dear students. As you can see, this is the diagram we have. This is our processing unit. It has a single instruction stream and a single data stream. As example, we have the IBM PC and we have the most basic embedded microcontrollers that we have. They are a perfect example of SISD machines. The next, more single instruction, multiple data, SIMD systems. SIMD machines are multiprocessor machines which are capable of executing the same instruction on all the processors at the same time, with each processor operating on a different data stream. Remember, we have only one instruction, but we have multiple data. These machines are well suited to scientific computing because they involve lots of vectors and matrix operation. Now, let me take an example for you to understand, for example, SISD. If I have, for example, cos 45, you see that I have only one instruction performing the cosine of a number, and I have only one data, which is the 45, and it forms the SISD because I'm performing just one function, which is the cosine of a single value, which is 45. But when you come here, a single instruction but with multiple data, it can be cos 45 plus cos 60. That is, you are performing the same instruction but you have multiple data on which you are performing it. So that's how you can look at it in order to better understand how this classification made by Flint was brought about. As you can see, this is the diagram we have. We have a single, we have many data pool. As you can see, data stream number 1, data stream number 2, data stream number n. So there are many of them. But we have only one instruction. And this instruction is divided for each of the processing unit. That is why we said which are capable of executing the same instruction on all the processors at the same time, with each processor operating on different data stream. So this unit has this data stream but a part of the instruction, different data stream, the same instruction, and so on and so forth. As example, We have the current GPUs, e.g. NVIDIA, and we have the Craze Vector Processing Machine. And take note, SIMD is a multiprocessor machine. The next one, multiple instruction, single data. MISD machines are multiprocessor machines capable of executing different instructions on different processors, but all of them operating on the same dataset. So here, what are we doing? We are performing different instructions on different processors, but on the same data set. That's what we are doing. Each processor receives a distinct instruction stream, but all operate on the same data stream. Such machine no longer exist. MISD machine do not exist anymore. And as example, as I gave for SISD and SIMD, MISD, you can look at it as, because you have a single data, because you have this same data is what we have here, and we may have different instruction. It's just like you have sine 45 plus cos 45, sine 45 plus cos 45 plus tan 45. You are performing different, you are doing different instructions. That is, this is sine, this is cos, this is tan, but on the same data, 45, 45, 45. That is how you can understand the MISD machines. Okay. The last one, which is the multiple instructions, multiple data system. MIMD machines are multiprocessor machines capable of executing multiple instructions on multiple data sets. They are n, they have n processors, n streams of instruction, and n streams of data. That is, each processor goes with a different instruction and a different data. Each processor element in this model has a separate instruction stream and data stream. Such machines are well suited for any kind of application. So these are just the best, what we say in French, la crème de la crème, MIMD machines. As example, you can take, for example, you are performing sine 45 plus 3 factorial. So you see that here we have two different instructions, the sign of a number and the factorial of a number, two different instructions, and they are operating on two different data because sine goes with 45 and the factorial goes with 5. So sine 45 plus 5 factorial. This is the diagram you have. So this processing unit goes with this data, and these are the instructions on which they are being executed. This second unit goes with this data and this instruction, and same thing until we have the end processing unit, as you can see. As example, we have multi-core computers. So these multi-core computers you have nowadays are perfect example of MIMD machines. Now, unlike SIMD and MISD machines, which are equally multiprocessor, because take note, we saw that out of these four different categories of computers, only the SISD is a uniprocessor. That is why it is equally called sequential or serial machine. The three others are all multiprocessor machines. Now, out of these three, there is one which differentiates from the two others. That's what we are saying. Unlike SIMD and MISD machines, which are equally multiprocessor, processing unit in MIMD machines work asynchronously. MIMD machines are classified into two categories. What do we have here? When they say they work asynchronously, means that they are not synchronized unless until, because SIMD have to be synchronized because although there are different data streams, there is only one instruction which is being performed. So they have to be synchronized in order to know which part of the data set will go to which processing unit. Same thing with this, whereby we have multiple instructions, but we have a single data. Now, MIMD machines are classified into two categories. We have the shared memory MIMD systems, also known as the tightly coupled, in which all processors use the same global memory and communication happens through it. Any change made by one processor is visible to all the others. That's why we say they are tightly coupled. They say they share the same memory. Example include the silicon graphics system. Shared memory systems are easier to program but harder to scale and more vulnerable to failures, since a fault can affect the whole system. The other one is the distributed memory MIMD system, loosely coupled. In this particular one, Each processor has its own local memory and they communicate through an interconnection network. It can be a star, it can be a tree, it can be a bus. Distributed memory systems are more scalable and fault tolerant since each processor is independent. And for you who might ask what is the meaning of fault tolerance is simply the ability of a system to remain performant despite the breakdown of a particular unit. That's what we call fault tolerant. And we are just from seeing that the distributed memory MIMD is more fault tolerant as compared to the shared memory MIMD. I hope you understand how we came about these four different categories of computers based on the taxonomy of Flynn. I hope you understood how these different machines work and the different example we have. See you in the next lesson. Thanks for your contribution through your like, your subscription, and your comments, which serves as a feedback for us. See you in the next video where we shall be looking at the processor and its component. Thanks and see you in the next video.